হ্যালো, হ্যালো জয়িত,
হ্যাঁ স্যার।
শোনা যাচ্ছে ঠিকঠাক?
হ্যাঁ,
আচ্ছা 100 জয়েন করেছে, আমার তো আর কিছু করার নেই।
আর বাকি যারা আছে তারা ইউটিউব লাইভ স্ট্রিম থেকে
হ্যাঁ, আর সেখানে আমার কোনো অ্যাকসেপ্টেন্সের ব্যাপার নেই তো, মানে আমি অ্যাকসেপ্ট করবো যেটা অ্যাডমিট করা হয় সেটা আমার কিছু কাজ নেই।
না যারা লিংক আছে তারাই ওরা মানে
তাহলে জয়েন করবে। আচ্ছা আমি মানে 12টা 5 টাইম দিয়েছিলাম, তো কি স্টার্ট করবো না দেরি করবো 4 মিনিটস? হ্যালো,
ইউটিউব লাইভে কজন হয়েছে সেটা দেখে বোঝা যায়।
তবে 4
স্যার
মিনিট দেরি করলে
স্যার এখন তো আর কেউ ঢুকতেও পারবে না, আপনি স্টার্ট করে দিলেও পারেন।
যারা ইউটিউবে আসবে তারা যদি দেরি করে,
সেটা
তবে
হতে
আর
পারে।
2 মিনিট, আর তো 2 মিনিটস বাকি আছে, ঠিক আছে?
আচ্ছা
2
স্যার।
মিনিটস, হ্যাঁ 2 মিনিট বাকি আছে, ঠিক আছে, হ্যাঁ। হ্যালো, হ্যালো,
স্যার।
হ্যাঁ, দেখছি যে ফুল অ্যাটেন্ডেন্স, খুবই ভালো লাগছে। তো এতজন সিরিয়াস, probably all are serious about that. I think this is the last laboratory class, is it?
No, sir. We are having our laboratory on 9th also. Actually, on 1st of January, we didn't have our laboratory, so we have arranged it on.
However, you have completed 8 laboratory.
Yes, sir.
So you are expert. So you are expert and also habituated, I think.
Yes, a little bit.
Little bit. But it is we are unfortunate the pandemic conditions. However, we have to complete the laboratory classes, etc. So
Yes,
my
sir.
experiment is experiment number 10. Okay. So have you seen me? Section B. Section B.
No, sir.
Why?
No, sir.
Why? Have you not find in my department? Just 1 year cover. 1 year cover. Yes.
Yes.
So, okay. So now we can start.
Yes, sir.
Window. The screen is visible. Hello, the
Yes,
screen
sir.
is visible. Yes. So the class will be interactive. Okay. So the interactive during any discussions on your microphone, etc. It will be totally interactive. The time is with our hand is 1 hour. So this is your experiment number 10, I think. Experiment number 10. The experiment is voltage and power characteristics of a ceiling fan. I think all you know about ceiling fan. Okay. Fan may be different types, table fan, ceiling fan, etc., etc. But we are discussing about, or we are performing about the ceiling fan. Okay. You know, this is the single phase motor. Actually, in true sense, it is not single phase motor. It is two phase motor. After this lecture, I will show you the animations which is provided from the department. Okay, I will show that. However, I will first like to complete the experiment. What is the experiment? How it is performed? What will be the report? What are the meters, etc., etc. And this is totally interactive. Okay, this is my name, etc. You know. The experiment is voltage and power characteristics of a ceiling fan. What is the objective? To study variation of power consumed by fan with and without regulator for the different supply voltages. Okay, so this will be your circuit diagram. This is your circuit diagram, detailed circuit diagram. How it is formed, how it will work, I will discuss this one first, then we'll go to the experiment. For any difficulties, please inform. What are the accessories required? This is the fan. I think you all of you saw that fan in your household. This is a household fan. It is actually single phase induction machine. Single phase induction machines. I think you have covered DC machines. Okay, you have heard the term single phase AC machine, induction
স্যার
machine.
স্যার
Yes.
স্যার প্রেজেন্টেশনটা না একটু অদ্ভুত দেখাচ্ছে, মানে প্রথম স্লাইডটাও দেখাচ্ছে, কারেন্ট স্লাইডটাও দেখাচ্ছে, মানে ঠিক করে স্লাইড শোটা লোড হয়নি। একবার বন্ধ করে একবার স্টার্ট করবেন?
আচ্ছা 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 শিওর। ও এইটা বোধ হয় নাকি? এইটা দাঁড়াও। এখন কি আসছে?
হ্যাঁ স্যার, এবার ঠিক আছে, এবার ঠিক আছে,
এবার ঠিক আছে?
এবার ঠিক আছে।
দাঁড়াও দাঁড়াও। এবার কি ঠিক আছে?
না, আবার সেই ইয়ে হয়ে গেল,
আবার হয়ে গেল।
আবার দুটো হয়ে গেল।
এটা আবার কি ব্যাপার বাবা? আচ্ছা, তা কেন হবে?
না, ও মানে কোন উইন্ডোটা শেয়ার করতে হবে ওটা হয়তো গুগল মিট ঠিক বুঝতে পারছে না।
আচ্ছা, তাহলে আমি আরেকবার করি এটাকে। আরেকবার করি। আরেকবার ট্রাই করি জাস্ট। এখন
না স্যার, আবার দেখাচ্ছে।
আবার দেখাচ্ছে একই সেম।
হ্যাঁ, এন্টায়ার স্ক্রিনটাকে প্রেজেন্ট করুন তাহলেই হবে।
আচ্ছা, stop presenting. আচ্ছা, প্রেজেন্ট নাও, ইন্টার স্ক্রিন। ইন্টার স্ক্রিন যদি করি, আমি আর 2 মিনিট নিচ্ছি, দাঁড়াও।
এবার ঠিক আছে স্যার।
আচ্ছা, এবার এটাকে ছোট করবো না? আচ্ছা, এখন ঠিক আছে?
হ্যাঁ স্যার, হ্যাঁ স্যার।
গুড, ঠিক আছে। ঠিক আছে, তাই তো? নাও উই ক্যান কন্টিনিউ। হ্যালো, নাও উই ক্যান কন্টিনিউ।
Yes, sir. Yes.
হ্যাঁ,
ওকে স্যার।
so this is the accessory. This is a ceiling fan you have find in your house, etc. Anywhere. This is actually single phase induction motor. You know the DC machines and AC machines. AC machines may be 2 types. You know, one may be synchronous machines. Another one is induction machines. Induction machine may be 2 types. One is 3 phase. Another is single phase. The fan used in our room is single phase one. Actually, in true sense, it is 2 phase induction machines. Okay, how it is becomes 2 phase induction machines, it will be discussed after the lecture. Okay, next one, we want the VARIAC, variable AC supply. This is known as VARIAC, to provide variable supply. It is actually a transformer, auto transformer. I think you know that. You heard this in this class. Here the input should be given, AC input should be given, and it will give you the variable AC output. Okay, variable AC output with same frequency as input frequency. Input frequency and output frequency is same, and it will give you the variable voltage supply. It may be step up or step down. Next one is regulator. Also you have find this. Regulator may be three types. One is conventional one is three types: resistive type, inductive type, and capacitive type. And the modern regulator is electronic type. Okay, resistive regulator is frequently used. Inductive regulator is also used, but very less amount. Capacitive, we can also use the capacitive regulator, but in market you cannot find inductive and capacitive regulator because they are primitive. Okay, for the low cost we are using resistive type regulator, and this is the resistive type regulator, and modern one is the electronic regulator. We will working here with resistive regulator and inductive regulator. So this is the main accessories. Now come to circuit diagram. This is your fan with which we have to work. This is your supply. You know the fan is used in house with 220 volt 50 hertz single phase supply. Connect this by fuse, then connect regulator, then connect another wires. So this is your circuit for running a fan in house. So this is your fan, this is supply 220 volt 50 hertz. Okay, this is fuse and this is regulator. Here we are using resistive regulator. So this is the circuit by which we can run the fan in our house. Okay, so we have to experiment on voltage and power characteristics of ceiling fans. Okay, this is our aim. In our laboratory, we are using 110 volt supply for the safety. Okay, but fan is working with 220 volt supply. How we will get it? For this we will use the variac. So this is your variac. Okay, in variac apply 110 volt supply, and this is your step up transformer. Actually, step up, it will give you step up voltage, and this is your variac. Okay, all other parts are same. Now connect these circuits, so it will give you the circuit for running the fan. Okay, so this is the fan. The rating is 220 volt. So we have to supply 220 volt, but in our laboratory 110 volt is available. So to provide 220 volt supply, we will apply the variac. Okay, so this is the circuit, but we have to do our experiment for voltage and power measurement, etc. For to do this, we have to use different meters like voltmeter, ammeter, wattmeter, etc. Okay, so these are the meters. This is your ammeter. I think you know that this is ammeter. Okay, ammeter may be DC or AC like this. So this is one type of ammeter. This is also multi-range ammeter. Okay, multi-range ammeter, using which you can change the range of the ammeter or rating of the ammeter. Then the voltmeter. Okay, this is voltmeter. Okay, you can you differentiate between AC meter and DC meters by physical inspection? Is it possible? Anyone? Hello?
স্যার সিম্বলটা একটু আলাদা থাকে।
না, সিম্বল আলাদা, সিম্বল মুছে দিলাম তাতে কিছু যায় আসে না। না, আমি বলে দিচ্ছি। আচ্ছা, জাস্ট সি দিস এসি ভোল্টমিটার। ওকে, this is the meter. Okay, আচ্ছা, actually this is AC meter. It is cramped. The scale is cramped here. Have you inspected this? The division are not equal. Suppose this is 0, this is 5, this is 10, like this. Okay, it will be discussed in your measurement class, etc. However, this is the voltmeter. This is ammeter, this is voltmeter, and another one is wattmeter. You know wattmeter measure the real power, VI cos theta. It has two coils actually. One is current coil, another is pressure coil or voltage coil. Okay, the deflection will give you the VI cos theta. Okay, so these are the meters to be used. Now go to the actual circuit diagram. So this was your circuit diagram up to this. Now we have to connect the meters. Now open the wire, connect the ammeter, okay, for measurement of current. Connect this. Then connect the wattmeter. You know wattmeter have two coils. One is current coil denoted by CC, another is PC or pressure coil. Okay, this is your common point. This is the common point. This is current coil. This is pressure coil. Now connect the another portions like this. Okay, how it will work? Acha.
Sir, what is the TOT?
Wait. Acha.
Sir.
This is your voltmeter. Okay, for input, for measuring input voltage across the fan only. And this is the voltmeter to measure the voltage input in the total circuit. Now come one by one. This is the ammeter. Okay, for measurement of current passing through the fan. Okay, I think it is clear. This is a voltmeter to measure the voltage across fan, and this is the voltmeter to measure the voltage input in the fan. Obviously, there is a difference. Okay, what is the difference? You know, the resistance of the ammeter is very low. Resistance of the ammeter is very low. Resistance of the current coil is also very low. Okay, but here is some resistance. Okay, so the voltage drop across resistance, and this one, it will give you this voltage. I think it is clear to you. Okay, so now come to the wattmeter. This is the current coil, current passing through the coil, and this is the voltage. This is the voltage coil. Okay, if it is connected here, then what will happen? It will give you the wattage consumed by the fan. How? It measures the current. It measures the current across the fan. Okay, voltage. What is the voltage? Voltage in wattmeter. The voltage across the fan. I think it is clear to you. Okay, so when it is connected with F, then it will give you the voltage, the power consumed by the fan. When this point is connected with TOT, that is total, then what happens? The current is same. Okay, what is the voltage impressed in the wattmeter? Just see, this is the total voltage, that is the input voltage. I think this is the input voltage. Okay, so when this portion is connected here, it will give you the power consumed by the total circuit. Is it clear? Hello?
Yes, sir.
Yes.
Huh?
Yes.
So this is TOT means total circuit. This TOT means total circuit. Once again, this is the wattmeter. It will give you the power, that is VI cos phi. Forget about, just avoid cos phi. The current flow for two positions are the same, but the voltage, if we are different. If we connect at the point F, then it will show you the power consumed by the fan. Okay, when it is connected with TOT, then it will give you the total power consumed by the circuit. Okay, the fan circuit, that is power consumed by fan plus power consumed by the regulator. Okay, so this is your circuit. Now you have to do the experiment. Report tap positions. Go to the previous. This is your regulator. I think this is your regulator. Okay, this is your regulator. So you would know there is different tapping positions. Okay, tap 0, 1, 2, 3, etc. Tapping positions. Tapping positions will be there. At tap positions 5, there is no resistance. Okay, at tap position 0, total resistance is there, and 1, 2, 3, etc. are there. Now go to tap positions 0 or 1, whatever may be. Now go to that table, the tap positions. Suppose it is tap positions 1. Then note that you have to fix the tap at tap positions 1. Then supply voltage. Okay, obviously it is 220 volt. The line current, that is current measured by the ammeter. Voltage across fan, I think it is clear to you. Voltage across, what will be the voltage across fan? Then power consumed by fan. Then total power consumed, power factor of the fan, you have to calculate this. Total power factor, you have to calculate this. So what are to be noted down? The tap positions. Go to that here. That is the tap positions is in regulator. Okay, voltage across fan, voltage, total voltage input. This is the total current, line current passing through the circuit, and voltage wattage consumed by the fan, and total power consumed by the fan. So you have to complete the table. Note that there are 4 to 5 tap positions there. So for each tap positions, you have to note down the tables, the readings. Okay, suppose for one position, supply voltage is V, obviously it is 220 volt. Okay, line current I, voltage across fan, suppose it is VF, power consumed by fan WF, okay, which is measured by the wattmeter. Total power consumed W in watt. Then power factor of the fan WF by VI. Okay, so it is single phase. That's why WF divided by VF I. Total power factor is W by VI. Okay, so now you complete the table. Okay, now go to previous slide. Now it is connected for resistive load, resistive regulator. Okay, it may be inductive regulator or maybe capacitor, but capacitive regulator. But in our laboratory, only resistive regulator is there. Okay, so we have to experiment with the resistive regulator for different tap positions. After that, just you have to connect the electronic regulator instead of resistive regulator. Okay, which has been shown in the very picture shown in the beginning. Okay, so calculate this and fill up the tables. Now come to the last portions, which is report. Draw the followings. Total input power versus tap positions. Okay, in the graph paper you have to draw. It is actually not graph. Actually, it will be the bar graph. Okay, I think you know the bar graph. So for different tap positions.
No, sir.
Huh?
What is bar graph?
bar graph, ঠিক আছে আসবো পরে আসবো আচ্ছা bar you don't know bar graph আচ্ছা okay for different tap positions you have to plot the input power. Okay, that is power fed in the total circuit. Then regulator loss versus tap positions. You know tap positions. What is regulator loss? You know the total input power. You know the power consumed by the fan. So just algebraic difference will give you the regulator loss. Okay, so for different tap positions you will get the regulator loss, and you have to draw the bar graph. Then fan input excluding regulator. Fan input excluding regulator, that is which is measured by the wattmeter when the voltage coil is connected at the position F. Okay, and it will be graph. You have to draw the graph, that is bar graph, corresponding to tap position versus input to the regulator. Oh, it's a regulator. Achha. Then comments on the variations of power loss of the fan for different types of regulator and at different tappings positions. You have to comment this. So this is your end. Now we can just repeat this. Just recap this, repeat this. So this is your study. This is your circuit diagram. I think you find there are two regulators. Okay, one is resistive regulator, another is electronic regulator. Okay, power electronic regulator. You have to perform two sets, one for resistive regulator, another for electronic regulator. Now we are discussing about one type of regulator, and other type of regulator experiment will be same. Only you have to replace the electronic regulator by resistive regulator. You have to replace resistive regulator by electronic regulator. These are the accessories and react to provide variable supply. Regulator, obviously this is resistive regulator and this is electronic regulator. Okay, now come to the circuit diagram. This is your fan, this is supply. You have to connect through switch. This is the regulator, obviously resistive regulator, and connect the other portions. The fan will rotate. Okay, and this is the circuit which is used in our house, etc. Okay, now you find that you see that the voltage is 220 volt. Actually, the ceiling fan which are used in our house, actually it is 220 volt supply. This is rating is 220 volt supply and 80 watt like this. Okay, 75 to 80 watt, more or less is 80 watt. Okay, so you have to apply 220 volt supply, so it's okay. But in our laboratory, 110 volt supply is available. To convert it from 110 to 220 volt with 50 hertz, we are using Variac, and the circuit will be like this. We are using here Variac, okay, to provide variable supply. Okay, now connect the other parts, and also it will run the motor. Okay, but there is no measuring units for measuring voltage, current, power, etc., etc. We will go to the next page. These are the meters: ammeter, voltmeter, and wattmeter. Ammeter for measuring current, AC current; voltmeter for measuring voltage current, voltage; and the wattmeter is for measuring active power, that is VI cos theta, VI power factor cos theta. Okay, so it has two coils. One is current coil, another is pressure coil or voltage coil. One of the current coil and one of the pressure coil are common. Okay, however, this will give you the wattage. Now come to the actual circuit. Connect the ammeter like this. Okay, then this is wattmeter, current coil and pressure coil. Two points are common. Okay, one is current coil, another is pressure coil. Now complete these circuits for providing the voltage. Now connect the voltmeter to measure the voltage across fan, and connect this voltmeter to measure the input in the circuit. Okay, now change the Variac to provide 220 volt in fan, and adjust the regulator. There are different number of tappings, 1, 2, 3, 4, 5, etc., etc. Note that tappings 1 for minimum speed of the fan, and tappings 5 is for maximum speed. That is, when you use tap 5, then resistive regulator is bypassed. Actually, total voltage will be increased on the fan. Okay, now for the report, complete this table. Tap positions for one regulator: supply voltage, line current, voltage across fan, power consumed by fan, total power consumed, power factor of the fan. You have to calculate this total power factor. You have to calculate this. You cannot measure the power factor by ordinary meter. To measure this, you can use the power factor meter. Okay, the supply voltage, suppose V, line current I, voltage across fan VF, power consumed by fan WF, total power consumed W in watt. Then power factor of the fan is WF by VF I, total power factor W by VI. Okay, now complete this. That is PPI report. Total power input versus tap position, regulator loss versus tap positions. Regulator loss means the total power consumed minus power consumed by the fan. Then fan input excluding regulator. Okay, fan input excluding regulator versus tap positions. Then comments on the results. Okay, so this is your complete experiment. Okay, have you any question up to that? Hello, hello, anybody in line?
Yes,
Hello,
sir. Yes,
শোনা
sir.
যাচ্ছে কিছু? হ্যাঁ,
Yes, sir.
হ্যাঁ,
Yes, sir.
have you any question up to that?
Yes.
আচ্ছা, no question. I think it is very much clear to you. হ্যাঁ, yes, yes.
Sir, what is dot? What is dot?
Tot is the tot. Actually, I have written tot. Actually, total.
Total.
Achha,
Oh,
wait. Actually, tot means what? If you connect this line here instead of this, it will give you the total voltage. That is, it measures the total power input through the input in the circuit. I think you would follow this. This is the current. If you connect this dotted line here instead of A, then what will happen? Come to wattmeter. The current, this is the current. Okay, no problem. The voltage is, it will give you the total voltage. Okay. So at that time, it will give you the total power consumed by the fan and regulator. Is it clear?
yes, sir.
Huh. Tot means total. Okay.
Okay, sir. Okay.
Anything else?
Sir, what is TAT?
What is
What is TAT?
that? Where it is? This one.
No, sir, I am saying that what is TAT? That means tap position.
Oh, tap positions. Acha. Acha, it will be clear after the animations. Okay, just note it. Okay, anything else? It will be clear. It will be clear. Acha. If not, then we can go to animation. Is it visible?
Yes, sir.
Yes, sir.
Yes, sir.
I think you find the teaching resource and interactive. Have you seen it?
Yes, sir.
হ্যাঁ,
Yes,
দেখা যাচ্ছে?
sir.
দেখা যাচ্ছে?
হ্যাঁ, হ্যাঁ।
আচ্ছা, ঠিক আছে, দাঁড়াও। Just see the lecture. Okay. আচ্ছা, এটা শোনা যাচ্ছে?
না স্যার শোনা
No,
যাচ্ছে না।
no,
No,
sir.
sir.
অ্যানিমেশনটা কি একটা লেকচার শোনা যাচ্ছে অ্যানিমেশনে?
না স্যার।
সাউন্ড আসছে না।
সাউন্ড আসছে না। আচ্ছা তাহলে এটা কি করে হবে? এটা শোনা যাচ্ছে না, একটু হেল্প করো। না আমি এখন বন্ধ করেছি, চালালে কি শোনা যাচ্ছে?
না, প্রথম দিকে শোনা যাচ্ছিল না।
না স্যার শোনা যাচ্ছে না।
আচ্ছা আমি একটু 1 মিনিট চালিয়ে নিয়ে জিজ্ঞেস করছি, ঠিক আছে, শোনা যাচ্ছে কিনা।
স্যার সাউন্ডটাকে বাড়ানোটা।
সাউন্ড বাড়াতে হবে, আচ্ছা।
খুব আস্তে
শোনা
আস্তে সাউন্ড আসছে, খুব আস্তে
আস্তে
সাউন্ড আসছে।
কিন্তু এটা তো বড় করবো কি করে, দাঁড়াও এই দিকটা। আচ্ছা এখন শোনা যাচ্ছে? শোনা যাচ্ছিল কি?
হ্যাঁ স্যার শোনা যাচ্ছে, তবে আস্তে।
অনেক আসছে স্যার।
শোনো, বোঝা যাবে, ঠিক আছে, আমি যা বলেছি ওটাই বলবে। আমি প্রথম থেকে চালাচ্ছি, হ্যাঁ চালাচ্ছি।
কি শোনা যাচ্ছে না সেরকম?
হ্যালো
স্যার ভিডিও সাউন্ডটা তো আরো একটু বাড়াবে ওখানে, দেখেন ভিডিও সাউন্ডটা আরো একটু বাড়ান ওখানে। হ্যাঁ
হ্যাঁ বেড়েছে তো, আচ্ছা আচ্ছা আচ্ছা। আমি একটু ইন্টারাপ্ট করছি এখানে। হ্যাঁ, তো দিস ইজ সিঙ্গেল ফেজ ইন্ডাকশন মোটর। ইজ অডিবল?
Yes,
I'm
sir.
audible?
Yes, sir.
There are two types of induction machines. One is three-phase induction machine, another is one is three-phase induction machines, another is single-phase induction machines. Okay, we are using single-phase induction machines in our house. Actually, what is this? If you provide three-phase supply in three-phase induction machines, it will generate starting torque. Okay, it will generate starting torque. The machine will rotate automatically, start automatically. But for the single phase induction motor, there is no starting torque. Okay, for two phase induction machines, there is also starting torque. Okay, to run a single phase induction machines, we are using two coils actually here. Okay, one coil this is known as the main winding, this is known as the auxiliary winding. There is some capacitor. Okay, so their impedance are different. Okay, phase difference is there. Okay, phase difference is there, so it becomes two-phase motor. When it becomes two-phase induction motor, two-phase motors, then it will start automatically. Okay, I think it is clear. Acha. Sometimes you have seen,
স্যার আরেকবার বলবেন ওই পয়েন্টটা?
ওটা আমি আরেকবার বলছি এটা শেষ করে নিয়ে বলছি আরেকবার। হ্যাঁ, তো বলছি কি, sometimes you find that some fans are not rotating in bus, tram or houses. Okay, if you just start, then it will rotate, it rotates. Okay, একবার বাংলায় বলছি, অনেক সময় দেখবে যে ফ্যান চলছে না, একটুখানি চিরুনি বা পেন বা এরকম হাত দিয়ে ঘুরিয়ে দিলে কি হয়, ঘুরতে থাকে, তাই তো? তার মানে হোয়াট ইজ দিস, উই আর ইউজিং স্টার্টিং টর্ক। ওকে, কখনো হয় if the auxiliary winding burn out or capacitor damage, then it happens. Okay, আমি টোটালটাকে আবার বলছি। In case of 3-phase induction machines or 2-phase induction machines, there is some starting torque. What is this? If you provide or apply voltage, then it will start automatically. Okay, but in case of single-phase induction machines, there is no starting torque. If you start or provide starting torque or force, starting, if you provide starting torque, then it rotates. Okay, আমি একটা তারপর একটা কি ডিসকাশন করলাম, sometimes we are find when capacitor is not working or damaged, if we rotate by some external means, it rotates. ওকে, তো বাড়িতে তো সম্ভব না যে সবসময় আমি হাত দিয়ে ঘোরাবো, তার জন্য করছি কি, ইউ আর ইউজিং 2-phase ইন্ডাকশন মেশিনস। হাউ 2-phase কামস, দেয়ার ইজ 2 windings. Okay, one is here, another is here. The impedance of 2 windings are different. Okay, so there is some phase difference between this current and this current. Okay, so it becomes 2-phase motor. When it is 2-phase motor, then it starts automatically. Okay, এবার বলো কে কি জানতে চাইছো বলো। হ্যালো,
না স্যার ঠিক আছে, ওইটাই শুধু ওই পয়েন্টটা মানে
হ্যাঁ ঠিক আছে, বুঝেছি। হ্যাঁ ঠিক আছে, আই থিঙ্ক নাও ইট ইজ ক্লিয়ার। হ্যালো, হ্যাঁ বলো। খুব ডিস্টার্বেন্স আছে, তুমি আবার বলো।
ফুলফল তুই মিউট কর।
হ্যালো, আমি জানি না, ওটা শুনতে পাচ্ছি না আমি আসলে। হ্যাঁ, তো ইউ ক্যান কন্ট্যাক্ট আফটার দিস। ওকে, আমি চালাবো। হ্যাঁ বলো বলো।
বলছি 3-phase ইন্ডাকশন এর ক্ষেত্রে তখন অটো রোটেট থাকবে 3-phase হলে।
অটোমেটিক, ওটা তোমাদের পরে পড়া হবে, ওখানে কি স্টার্টিং টর্কটা একা হয়ে যাবে, ঠিক আছে, মানে ও একা স্টার্ট করে যাবে, একাই রোটেট করবে।
3-phase ডাবল ফেজ হলে একা স্টার্ট হবে, আর সিঙ্গেল ফেজ হলে তখন হবে না।
না, হবে না, তুমি অন্য যে কোনো ফেজ, 2-phase, 3-phase, 4-phase, মাল্টি-phase, rotating magnetic field will be generated there, and due to which the motor will start automatically. Okay, so it is starting torque. Actually, for that machine, it has starting torque. Okay, but in case of single phase induction machine, there is no starting torque. Okay, আচ্ছা, এরপর যদি কিছু জানা থাকে তুমি আমাকে পরে ফোনে জিজ্ঞেস করো। Okay, now we can start this.
Results in a rotating magnetic field so that the rotor starts rotating. The coil connected with the capacitor has a leading phase, and accordingly the direction of rotation of the rotor is clockwise as shown in the figure. In order to control the speed of a ceiling fan, a current limiting voltage regulator is used in series with it. This is the circuit diagram of a ceiling fan used in our home, along with an on-off switch and a speed regulator. 3 types of regulator are used in practice. These are the inductive regulator, the resistive regulator, and the modern electronic regulator. Inductive regulator has less amount of power loss compared with the resistive regulator, but inductive regulator is much costlier than the resistive regulator. Also, inductive regulator decreases the power factor of the overall system. Resistive regulator has improved power factor over inductive regulator, but dissipates much more power with increased losses. However, resistive regulator is widely used because of its low cost. Electronic regulator has negligible losses, and nowadays it is very commonly used in modern houses.
আচ্ছা।
In our lab experiment, we will observe the characteristics of a ceiling fan along with a speed controlling regulator. Now, let us come to the experimental guidelines. In the experimental setup, this circuit is constructed in the laboratory with the fan as the load. Now our object is to study the voltage and power characteristics of the ceiling fan along with the performance of the regulator that is used in our houses. 110 volt AC 50 Hz supply is given to the circuit with the help of a switch and a fuse. Since our ceiling fan operates from household mains of AC 230 volt 50 Hz supply, a variac is used in the experiment to step up the input voltage because our laboratory supply is restricted up to a maximum of 110 volts. A voltmeter is connected at the output of the variac to measure the line voltage, and an ammeter in series to measure the line current. A speed controlling regulator is connected in series to evaluate its performance. The regulator can be resistive or inductive or electronic. A wattmeter is connected in the circuit as shown. Since a wattmeter measures power, both voltage and current measurement is necessary for the meter. The pressure coil measures the voltage, so it is connected across the supply, and the current coil measures current, so it is connected in series with the circuit like ammeter. If the common point of the pressure coil is connected here, then the wattmeter measures the total power of the circuit, that is, wattmeter measures the power of both fan and regulator. And if the common point of the pressure coil is connected here, then the wattmeter measures only the power consumed by the fan. Another voltmeter is connected across the fan to measure the actual voltage that is supplied to the fan operating at different speeds. Now comes the experimental procedure. The supply is given to the 110 volt input terminal of the variac. The main switch is closed. The regulator is kept at its maximum tap, that is highest speed. The variac is then adjusted so that the line voltage reads 230 volts. At this setting, the fan is rotated for 5 minutes to make the system stabilized. The regulator is switched to its lowest tap, that is the lowest speed. Readings of all the meters are taken. For each position of the regulator, the wattmeter readings are taken twice with regulator and without regulator. This procedure is repeated for all the taps in the regulator. When readings from one regulator are complete, the regulator is changed and the same procedure is repeated for the other regulators that are supplied in the experiment. This is the experimental data table of a typical resistive regulator that needs to be submitted after the experiment. Similarly, data tables are obtained for other regulators. The reports that are to be submitted are given here. Bar graphs of the important parameters for each type of regulator that are supplied during the experiment. These are the total input power versus tap position, regulator loss versus tap position, fan input power excluding regulator versus tap position, and comments are required on the variation of power losses of the fan for different types of regulators at different tapping positions. With this background, you can now proceed to the laboratory to perform the experiment. Thank you.
Simulation.
Schematic circuit diagram for studying voltage and power characteristics of a ceiling fan. The schematic circuit will be gradually transformed to the actual circuit by replacing the schematic circuit component with the actual component. Let's see the circuit components now. The variac to provide a variable input voltage to the circuit. The voltmeter to measure the line voltage. The ammeter to measure the line current. The wattmeter, the power of the fan. The resistive regulator to regulate power consumed by the fan. Another voltmeter connected to the two fan terminals to measure the voltage across the fan. The wattmeter has its current coil connected in series to the circuit. One of its pressure coils is shorted to a current coil terminal and another left free to connect to either of the regulator so as to measure the power of the fan with or without the regulator. Finally, observe the fuse and the switch connected on the board.
Cute. Hello? Hello?
Sir.
Actually, you have to perform the experiment like this in our laboratory. Okay. This is actually board which are available in our laboratory. Okay. Just see this. Okay. Acha. Wait a minute. Regulator. আচ্ছা স্ক্রিনটা কি দেখা যাচ্ছে? নেটের স্ক্রিনটা
হ্যাঁ স্যার।
দেখা যাচ্ছে? মানে মাউসটা দেখা যাচ্ছে? একটা ফ্যান ওই মোটর লাগানো আছে, রেগুলেটর লাগানো
হ্যাঁ হ্যাঁ হ্যাঁ
আছে তো। আচ্ছা, যে জিজ্ঞেস করছিল হোয়াট আর ট্যাপ, হোয়াট ইজ ট্যাপস, অ্যাকচুয়ালি রেগুলেটর ইজ লাইক দিস, ওকে, রেজিস্টার রেগুলেটর লাইক দিস, ওকে। হ্যালো হ্যালো,
Yes, sir.
regulator is registered like this. Here it is written 1, 2, 3, 4, 5, etc. Okay, so this will be the tap position. Okay, tap number 1, tap number 2, tap 3, tap 4, tap 5. Okay, when it is connected at 5, at tap 5, then there is no resistance in the circuit. Okay, and at that time it will give you the full speed. Okay, when it is connected with 1, then speed will be minimum. Okay, when it is connected with 0, then it is off actually. I think it is clear to you. Okay, আমি এটা কেটে দিচ্ছি। আচ্ছা, এটা কেটে দিই নাকি, এটা কেটে দিই, 1 মিনিট দাঁড়াও, আর কি আছে দেখি। আচ্ছা, দিস ইজ বার গ্রাফ। ওকে, এটা কি জিজ্ঞেস করছিল তা এক সময়? হ্যালো হ্যালো হ্যালো,
Yes, sir. Yes,
এই
sir.
কেউ জিজ্ঞেস করছিল একজন, হোয়াট ইজ বার গ্রাফ অ্যাকচুয়ালি দিস উইল বার গ্রাফ, নট গ্রাফ, হ্যাঁ, ভিআই কার্ভ লাইক, নট লাইক দিস। ওকে, ট্যাপ পজিশনস 1, ওকে, this tap position 1, 2, 3, 4, 5, etc. And these are the power, measurement of power. Actually this is bar graph. Okay, I think most of you know that. Okay, আচ্ছা, এবার বলো, I think all our query are clear to you. Now we can discuss. কার কোনো query থাকলে বলো। If you have any query, then call me, then you can ask me. হ্যালো জয়িত, হ্যালো,
Yes, sir.
হ্যাঁ শোনা
Yes,
যাচ্ছে?
sir.
হ্যাঁ,
সব শোনা
যদি আমার মনে হয় যে একদম সোজা এক্সপেরিমেন্ট, এর থেকে বেশি বলে লাভ নেই।
Okay, sir.
হ্যাঁ, দাঁড়া, আমি আরেকবার জাস্ট কনক্লুড করে ছেড়ে দিচ্ছি, ঠিক আছে?
Okay, sir.
আচ্ছা, স্লাইডটা দেখা যাচ্ছে?
হ্যাঁ স্যার।
Yes, sir. Yes, sir.
হ্যাঁ, আমি ওইটাকে জাস্ট একবার দেখিয়ে নিয়ে ছেড়ে দিচ্ছি। So I like to conclude this. Our experiment is voltage and power characteristics of ceiling fan. What is this? You have to measure the power, voltage, current, etc. And you have to inspect the power consumed for different voltage and for different positions for different type of regulator. This is our aim. So this is your circuitry. This is fan. This is supply, 110 volt. In our laboratory, actually, 220 not available. 220 available, but for experiment purpose, we are providing 110 volt for safety. Okay, but rating of the fan is 220 volt. So we are using variac voltage, variac, to give you the step up voltage, which is a 220 volt supply. Okay, the different meters are there. Ammeter for measurement of current. This is for measurement of power. This is for measurement of voltage across the fan, measurement of voltage input to the fan. There are two regulators, resistive regulator, and this is electronic regulator. Okay, we have to use both in separately. Okay, now what is the procedure? Just increase the voltage and apply 220 volt. Set different tap positions for one regulator and take all the readings and then calculate power factor, etc., etc., and then prepare the report. This is your experiment. I think it is clear to you. Okay, if you find any difficulties, then you can call me. Okay,
স্যার বলছি আমাদের কি কিছু লিখতে হবে ল্যাব রিপোর্ট টাইপের?
না শোনো, আমি জিজ্ঞেস করেছিলাম এখন কোনো স্ট্র্যাটেজি ঠিক হয়নি, ঠিক আছে?
ওকে স্যার, ওকে স্যার।
এখনো কোনো স্ট্র্যাটেজি ঠিক হয়নি। আমি যা মানে যিনারা ওই অ্যাডমিনিস্ট্রেশনে আছেন আমি জিজ্ঞেস করেছি কালকে, তো এখনো পর্যন্ত কিছু স্ট্র্যাটেজি দে হ্যাভ নট ক্লিয়ার করেনি আর কি, কিছু ক্লিয়ার করেনি। যদি ক্লিয়ার করে আমি বা কেউ তোমাদের বলে দেবে, ঠিক আছে? হোয়াট মে বি দ্য ইভলিউশন।
ওকে স্যার, ওকে।
হ্যাঁ, আচ্ছা আচ্ছা, আর কি হেল্প
ওকে স্যার।
আর কি হেল্প করতে পারি? আর তো সবই মেটেরিয়াল তো দেওয়া আছে, মেটেরিয়ালস ইজ প্রোভাইডেড অলরেডি। ওকে, হ্যালো,
ওকে স্যার।
হ্যাঁ ঠিক আছে, ঠিক
হ্যাঁ
আছে, ওকে, থ্যাংক ইউ।
থ্যাংক ইউ
থ্যাংক ইউ।